Okay, so today we're going to talk about segment and angle addition postulates. Um, Essential question, how do I find the length of segments and measurement of angles? And we're going to try and understand the basics of segments and angles. We're going to be talking about coordinates, congruency, construction, midpoint, bisect, segment, bisector, vertex, and a degree. Okay, first off, what is a coordinate? A coordinate is just the location of a point. You guys know what a coordinate grid is. Okay, the coordinate grid, right, in the XY plane. Okay, the location of a point. I think we did this the other day. Just want to double check. Keep in mind when I get a coordinate, let's say I was at the coordinate 2, 3. I tell you what, 2, -3. Remember the first coordinate I see tells me to go left or right. The second coordinate I see tells me to go up or down. So this coordinate 2, -3 would be 2 units to the right, 3 units down. Okay? That's just the location of a point. Okay? Congruent means identical. Congruent means identical. Right? Everybody say this with me. Congruent means identical. Now this time everybody really say it with me. Okay? Here we go. Congruent means identical. That won't be too much rah-rah, right? That's good. What does congruent mean? Identical. Be exact same. Okay? Congruent means be exact same. Okay? If things are similar, are they congruent? Things are similar, are they congruent?
No.
Sometimes. Okay? If things are congruent, are they similar? All the time. I know, it's really weird, right? Check it out. See that big red thing back there? Right? What shape do we call that? A rectangle, right? See one of these little building brick things? What do we call that? Is that a rectangle? Is that a rectangle? Are they similar shapes? Are they congruent shapes? Are they identical? No, they're not, right? Okay? Check this out. This brick right here. What shape is it? What about this one? Okay, are they similar shapes? Are they congruent shapes? All right, see it, right? So sometimes similar shapes are also congruent. All the time, congruent shapes are similar, right? We don't think like that in everyday life. I know. It's part of our study of geometry, all right? But congruent means identical, they have identical measurements. All right? I promise, you don't know the definition of congruent, you will fail this class. I'll say it with a straight. You don't know the definition of congruent, you'll fail this class. The most important word of the class is right there, congruent. What does congruent mean? Identical. Okay? So let's see. Congruent means, good. So most of you are going to pass. All right? That's good to know right now. All right? All of you are going to pass. Know what a congruent is. What congruent means. Okay? A construction. Construction is merely a representation of a segment, an angle, or shape. A representation of a segment, an angle, or a shape. Okay? So when we say construction, right, that means I am drawing a segment, an angle, or a shape. We will work with compasses to figure out how we can freehand, or not freehand, but whatever you call using your instruments to develop your construction. We'll do that later, and we'll also do that with shapes. We'll do that with segments and with angles. We'll learn a little bit about constructions and geometric principles. Okay. All right. All the big ones. Okay. These are midpoints, bisect, and segment bisector. I'll read it. The midpoint of a segment is the point that bisects, which means divide the segment into two congruent, there it is again, segments. The segment connecting the midpoint is called the segment bisector. Okay, this one's loaded, right? I first have what we call a midpoint. What is the giveaway for midpoint? Where would the midpoint be? The beginning, the middle, or the end? Middle, right? Midpoint. I don't know this for a fact, but you guys don't know that I don't know this, so let's just say that midpoint is short for middle point. Okay? There, made it easier. Okay? The middle point of a segment is the point that bisects. Oh, bisects. Yeah, that word, bisects. Okay? Here is some life examples. Bisects. What does this prefix mean? Bi. Two, right? Can anybody give me some life examples of bi? Yeah, it's not wrong. It's maybe hoping for bicycle. But bisexual. Bicep. How many muscles do you have in your bicep? I have no idea, got speed. Okay, but yeah, let's go for two. I would say that a bicep would have to be two. Okay, a bisexual, somebody has or likes or whatever, two different types of sexes. Okay, bicycle. What's that? Tricep, not two, but three. Okay, all right. So when we say that, it will give it all away. You'll know this from my heart here pretty soon. Okay, when we say that something bisects a segment or bisects an angle, how many parts is it getting divided into? Two parts. We'll see why, right? It is that literal, but it's that simple. A bisector will cut something into two parts. If it is a segment bisector, it's cutting a segment into two parts. Okay? If it is an angle bisector, it's going to cut an angle into two parts. Quite a literal definition, right? All right, so let's see this in action. We're going to get to that. So that last slide is kind of what our lesson is going to be on today. We'll talk about that in a little bit. I do have one more. The measure of an angle is usually given in degrees, right? Since there are 360 degrees in a circle, 1 degree is, fill in the blank. How much of a circle is 1 degree as a fraction? What? Nope. One over 360. Yep. It is 1/360th of a circle. Right? 1/360th. 360 total degrees. How many of those total degrees is one of them? 1. Right? 1/360. So we are clear on something else, because we're still early enough for me to be able to say these things. Which of these numbers is the denominator? Yeah, the bottom, which is 360. Which one is the numerator? 1. Okay? So when y'all thought of fractions in the past, did you think of top and bottom or numerator and denominator? What? Okay, so which is fine, but now we're going to talk about numerators, denominators. Okay? Numerator, denominator. Numerator is on top, denominator is in the bottom. Right? In 2nd grade, when they made me think about numerator and denominator, my 2nd grade teacher always said denominator. Okay? If you knew how to spell denominator, it starts D-E-N, and it has omerator after it. Okay? It was D-E-N. What is D-E-N? The den. Okay? What do y'all call in your house? Where is the den? In the basement. Where's the basement? Downstairs, which is in the bottom, right? We had to do all that in 2nd grade, and I was like, our den is not in the basement, but it's okay, right? So yeah, right. So if your den's in the attic, then no. So everybody, the denominator is in the bottom, the numerator is on top. Okay. All right. So we got our first postulate of the year. Whenever you see something like this up here, typically I'll let you know if you need to write this down or not. Here's what you need to write down on this. You definitely need to write down the segment addition postulate. And then if you want to, you can write the definition. Like if you're a word person, you know, if you like to think about things in terms of defining them. However, the beauty of geometry is that most of the time you're going to have an example with it. Okay? If you're really studious, which I hope you are, write them both down. All right? You definitely have to write down segment addition postulate. All right? Here's our segment addition postulate. If point B is between point A and point C, then line segment AB plus line segment BC equals line segment AC. Think of it linear, yes, but we're not putting this on. So when I hear linear equation, I think like the next plus B, right? This is way easier than that. Should be, okay? All right. Matter of fact, whenever I do this problem, here's typically how I think of it. I am a visual type of learner sometimes. Sometimes I'm not, but sometimes I am. Hey, every time I think of a line segment, I always think of a map. Okay? Map. So we got 3 towns. We got Atlanta, Buckhannon, and Buckhannon between Carrollton and Atlanta. Give me something in Alabama so I can see. Center, perfect. We got the APL, we got the Buck, and then we got Center, Alabama. Okay, and it's not perfect because those aren't quite, you know, exactly how you go to center. But check it out. I'm interested. I think we're there. Okay, I'm interested in knowing how far it is from Atlanta, Georgia to Center, Alabama. And let's just theoretically say that Buckhannon is between those 2 towns. All right? Well, I'll tell you who this is. From Atlanta to Buckhannon, 35 miles. I'll make it equal. 30 miles. Okay? So from Atlanta to Buckhannon is 30 miles. Right? From Buckhannon to Center, Alabama. How about 50? Okay, 50 miles. How far is it total from A to C? That's all we're doing. All right? But we don't need to worry about linear equations, right? You know what I'm saying? We're way easier than that. From A to B is 30. From B to C is 50. 30 plus 50. right? That's all this tells me to do. Y'all see that? AB, which is 30, plus BC, which is 50, equals what? 80. Okay? Then we get problems like this. It says G is between F and H, FG equals 6 and FH equals 11 times GH. And you get to the very first tip of the year. Tip, like math tip, like your teacher telling you how you can solve these problems. Okay? First tip of the year. All right? Don't be late. Don't fail classes on purpose and get kicked off that. Oh, now let's okay? All right, check it out. Here is the first tip of the year. Yes or no, this is a word problem. Yes, it's a word problem. How do you know it's a word problem? Got words. Got words. Doesn't have a single diagram, just got words and numbers, right? Okay? Whenever you get a word problem, draw a picture. Boom! Whenever you get a word problem, draw a picture. I tell you what, I'll make it real simple. If you want to fail this class, don't read the problems and don't write anything. If you want to get a C in this class, read the problems and take a random guess, and sometimes you'll be right. If you want to make a B in this class, read the problems, draw a bad picture and the wrong picture, and most of the time you'll be okay. If you want to make an A in this class, read the problem, reread the problem, make sure your picture is correct, use that to solve the problem. Okay? You're going to fit in one of those four categories. You got me? Read the problem. G is between F and H. Stop. How many points do I have? 3. What's the first point? F. Very good. See? F is the first point, right? It's not G. Because G is where? In this picture is G between F and H. There we go. Right? That's all I got to make sure I'm doing. It's a line segment. It doesn't tell you that, but you know that they're points, and it's a line segment. Okay? You'll see why we draw a picture so far, right? Not quite done with my picture. I need a little bit more information. What other information do I need? F to G is 6. And what is it? Oh, so the total from here to here is 11. And what am I looking for? So when it says find GH and you're filling in your picture because you want to make an A, right? You put a question mark, right? And then you can put an X if you wanted to, all right? So now you know you've given yourself the question to solve, right? Okay? So think about this. We go back to this one. If I had this information up here, 80 total miles from Atlanta to Center, Alabama, right? 30 miles from Atlanta to Buckhannon. How far is it from Buckhannon to Center? 80 minus 30, right? What am I going to do right here? 11 minus 6 is 5. And hot dog, I've got G to H is 5. Right? See it? So get used to it. I got a word problem. What's your tip that you should do? Draw a picture. I've drawn my picture. I filled in the missing information. Solve the problem. Okay? That works. Word problem, read the problem, draw your picture, and then you're rocking and rolling with it. Okay? All right, y'all do this one. Let's see how we do with it. I know there are. Okay? Your best. Okay? Set up the problem. You've got we'll go 2 minutes, okay? Set up your problem, try and solve it. Shouldn't take that long. It's going to be a multi-step equation. Do your best. We'll work this out here in just a second. How you did. You check your work with mine, okay? All right, here we go. N to M plus M to O equals N to O. All I need to know. How much is N to M? 17. How much is M to O? 3x minus 5, right? How much is N to O? Okay? So just like our warm-up problem, I've got a multi-step equation that's coming up here, okay? Unlike our warm-up problem, I first have 17 and minus 5 that I need to deal with. That's what? That's 12. 17 minus 5 is 12. Good job. Now we can just get you to turn your homework in, you'll be all right, okay? But that's okay, man. You got subtraction down, all right? Here we go. 3x minus 12 equals 5x plus 2. Which one's bigger, 5x or 3x? 5x, okay, good. So I subtract 3x from both sides. Okay, that's 0. This is 2x. If I did that, right, if I went from left to right, I now got to go right to left with the real numbers. I'll subtract 2. Oh no, that horrid state, I have to have a negative number here. So let's see how it is. Negative 12 minus 2. Negative 14. See, man, you tell your sister, you got it. Okay, now I'm done with adding and subtracting, right? I finished all my adding and subtracting. I'm going to move to multiplication and division. I'll divide both sides by 2 here. Okay, negative 14 divided by 2. What's that? Negative 14 divided by 2. Negative 7, not positive 7, okay? Makes a difference, right? Here's why it makes a difference. If I plugged in 7 for x right there, I doubt that I would get the right answer. Okay? So, 3 times negative 7. What's that? What did I do wrong? Why didn't y'all tell me that? I was wondering about it. Plus 12. 10. Why didn't you tell me that? Why didn't you tell me that when I did it on board? You trying to make me look foolish. That's mean, man. It's a sin, okay? What? All right. 12 minus 2 is 10. 10 divided, okay, we'll do redemption here. Wait, so what is 10 divided by 2? Good, okay? So 5 is equal to x. All right? 5 equals x. Okay? Hey, is the right answer negative 7 or is it 5? Good for you. Okay? So I got 5 here, okay? You'll see what I did. I put 3x minus 12 instead of 3x plus 12. Did I do something else wrong?
Oh, no, I'm saying like where the 5x and 3x is.
Yep.
It's supposed to be 2x in the green.
3x minus 5 in the green.
Yeah, on the right side, like right after the.
5x plus 2, 5x plus 2.
No, I'm saying like
I think I did that.
when you subtracted 3x from the 5x.
5x minus 3x is 2x.
Oh, it looks like an 8.
It's 2. I'm not that bad. All right, so hey, plug in 5 right here. Okay, what's 3 times 5? 15. What's 15 minus 5? 10. So this should be 10, right? What's 5 times 5?
25.
What is 25 plus 2?
27.
That's okay. Confused on Mr. Hobbs. I'll be here all semester. Okay, you hopefully will not be though. All right. What's 3 times 5? Good. You're good at this. What's 15 minus 5? See, confused button. All right. We got Cameron back. All right. So it's 17 plus 10, 27. Yes, it is. Okay. 17 plus 10 is 27. All right. Woo. I'm gonna see how many we got left. Okay, I got 3 more I got to do, but I'm gonna give you your break first. So longer than we needed to. Next up says D is the midpoint of EF. ED is 4x plus 6, and DF is 7x minus 9. Find E to D, D to F, and E to F. All right, there's a keyword in there that tells me all that I need to know. Fine. It starts with an M and it ends with midpoint. 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 What's your definition of midpoint? Middle.
Well, I say, all right, the midpoint is where the point is. A segment.
What's your definition of midpoint?
Middle point.
Wrote it down.
Midpoint of the segment is the point that bisects.
It bisects it into what?
Two segments.
To what kind of segment? What does congruent mean?
Identical.
It means
Identical.
Thank you. There we go.
Identical. I got that one.
I hear you. Okay, believe me. Identical. And identical. Okay, identical in this context will mean equal, right? So think about it. That means that E to D is equal to D to F. So 4x plus 6 is equal to 7x minus 9. Right? Let's see how that works. Okay. That wasn't that bad. Okay. So what's bigger, 4x or 7x? 7x. Good. So I'll move 4x from the left to the right. I'll move 9 from the right to the left. And last time I did this, I messed up. So I'll make sure y'all have me corrected here. 6 plus 9, I'm pretty sure is 15. Is that right? Yes, it is. Mr. Kent, what is 15 divided by 3? 5. Thank you, sir. Mr. Kent, is 5 my answer? Mr. Kent, why is that incorrect?
I don't think you have it.
Yeah, I didn't ask to solve for x, did I? No, see, right? 5 is not the correct answer because it wasn't the question that I asked. See it? Okay, and this is where this class will trip you up, mess you up, take you through the washer and dryer, and bring you out to dry. Whatever that all meant, all right? Hey, listen up. The key to this class, and it's a very simple phrase, but the key to this class is answering the questions that I asked, right? If I said solve for x, what's x? This is the right answer, correct? If I say find e to d, d to f, and e to f, this is not the right answer, is it? On your EOC, okay, on your EOC, don't be surprised if they ask a question like this and 5 is one of the choices.
You did all that problem.
All that just proved point. What's the point I'm proving?
You gotta find E to D, D to F, and D to F.
Now find E to D and D to F, find E to F, right? Hey, plug in 5 right here. 4 times 5 is what? 20. 20 plus 6 is what? Check it out. If I do that right there, what do y'all think this is going to be? I bet it's going to be 26 as well. To prove it, 7 times 5 minus 9, 35 minus 9 is 26. Okay, I ain't got to draw an equal sign. I got to add 26 and 26, which should be 52. Okay, so E to D is 26, D to F is 26, E to F, 52. How did I get 52? 26 plus 26. Okay? Yeah, so I got to have X to find E to D and D to F.
E to D.
But my point is that but 5 isn't the right answer because it's not the question that I asked. So think about this as almost 2 problems in one, right? I got to solve for X, that's step 1, and then I got to plug X in, and that's step 2, right? Yes, sir.
So, like if it said, so like if you were just answering the question, so you say, you found E to D would be 26, and then you found E to F would be 26, and E to F would be 52. And so, just like that, that's how you do it.
This is exactly what you do right here. You would circle it, and then some of you will put like smiley faces and all sorts of stuff with it, okay? You know what I mean? Some girls, so my name's B-R-I, and some people do the little heart thing above the, and that looks really weird. Okay? They will, and the handwriting's pretty good. Okay? All right, hey, check it out. I told you we got to do segments, and we have to do angles today. So the angle addition postulate, okay? The angle addition postulate is simply this. If S is in the interior of angle PQR, remember I told y'all it would look like this, the angle symbol, it no longer means less than greater than, now it means angle, okay? Then the measure of PQS plus the measure of SQR equals the measure of PQR. Oh, okay. Sure, Mr. Bob. All right. Let's look at it in context. Check it out. The measure of DEG is 115. The measure of DEF is 48. Find the measure of angle FEG. Let's back up. Okay, let's back up. I've given you a partial picture, so you don't have to draw the whole thing yourself, right? All right, let's add in this information that's key. Before I do this whole DEG is 115 thing, okay? Because it's true, but I want to make sure I see this, okay? What is DEF? How many degrees?
48.
48 degrees. Guys, that means that that measurement right there is 48 degrees. What is FEG?
You don't know.
We don't know. And if we don't know in math, we're going to put a question mark or an X. Right? Now know this. Okay? If we don't know, then we're just going to go like this. That is that many degrees, right? We don't know. That's what we're going to find. Okay? Now, I have the ability to use different colors. You guys don't. Okay? What is the total of these two supposed to be? 115, right? So the total, notice I'm doing this in red. When I'm going to add those two blue angles together, the total is going to have to equal 115 degrees. Okay? Right?
You gotta find something to get.
Well, see how they put this as an equation? Okay, you're going to do the same thing. The big equation is going to be the following. The measure of angle DEF plus the measure of angle FEG will equal the measure of the big angle DEG. Okay? Right? After a day of working this, you'll just be putting numbers here. Here's why. How much is DEF?
48.
48. How much is FEG? No. How much is FEG?
Oh, you don't know.
We don't know. It'll be X. How much is DEG? Y'all see how you gotta make your transition? This is the geometry, right? Here's our geometric postulate.
So we're doing some.
Angle addition postulate. Yes. What is our algebraic
48.
expression? Yeah. 48 plus x equals 115. Okay. Now look. I do this every year. Okay, and it gets. How many of you do not know how to solve that? Come on, man. Just can't.
I know what it is.
Isolate x. How do you get 67? Guys, it's a one-step equation, right? I subtract 48, correct? X is x by itself now. Yes. X is 67 degrees, right? What was x representing? FEG. What did the question ask me to find? Do I have to do anything else?
Nope. Why are they? I just don't get why they're fancy on it. They're making it more complicated than that.
Well, really not, because the postulate is as simple as you have to get, right? But because you guys are used to these, I'll make the transition for you, okay? All right. So here is the big teaching principles, right? The thing written in black is the geometry part, right? You'll see that? That's the geometric postulate. The blue stuff is all algebra. And walking into class today, everybody in here is expected to know how to do the blue stuff, okay? I'll do it for a little bit, like for a few weeks, because y'all not had math for a year, some of you maybe longer, right? But like, after a few weeks, that's all you're gonna get from me, okay? I might write an equation up here to help you get started. Y'all see that? But this is the part that you guys will do on homework assignments. This is the part that you've got to perfect, okay? This is the only new thing from today. Y'all see that? This wasn't new. This was old stuff, all right? Okay? I'm going to look at one more. I don't know if we'll do it or not. I got a minute and a half left. Let's fill in the information. Same deal, okay? XWZ is 121. XWY is 59. You'll see how we do this now? Here's 59. We're trying to find YWZ. The whole thing is 121. You'll see what you get. Mr. Hobbs, do I have to set it up as an equation? Nope. What could you do here? In one step. Take 121 minus 59. Try it. Try it. Oh, you don't care what it's coming out. No, you can do it on there. I'll do it. 121 minus 59. Man, we don't need a phone. Can one line? No. So that's 1, 2, 2, no. 62. Right? 62. That's it. Okay? That's all you got to do. I'm getting some maybe unsure looks. So let me do a formative. Let me do a quick stop and check. Okay? Holy smokes. This is as long as it is. 1, 2, or 3. Okay? So you're going to raise your hand. 1 means you have no idea what's going on. If I ask you second addition postulate and angle addition postulate, you're as clueless as you were when you walked in. 2 is you're kind of sure, but maybe 1 or 2 more problems would be okay. And a 3 is, please, dear Lord, stop talking because I can no longer hear your voice. What does that mean?